Welcome back to the deep dive. Last time we really got into the nuts and bolts of how these large language models are trained.
Oh, yeah.
But today, we're switching gears a bit.
Okay.
Getting ready to uncover the magic
Right.
of how these models actually generate
Yeah.
those mind-blowing results you've been hearing about.
It's like a whole different perspective, right? We were like obsessed with those billions of parameters adjusting during training.
Right?
But the real fun starts
Yeah.
when the model actually gets to apply its knowledge.
Exactly. Like spending years mastering an instrument and never actually performing for an audience.
Right.
So today we're diving deep into the world of inference.
Okay.
The stage where an LLM gets to strut its stuff.
It really is where things get interesting.
Yeah.
I mean, the model's not actively learning anymore.
Right.
Parameters are set.
It's done with school.
Yeah, it's like graduation.
Yeah.
It's all about putting those hard-earned skills to work.
Okay, so let's break it down.
Sure.
What happens when you give an LLM some text,
Yeah.
like a prompt? How does it even begin to process that information?
Well,
Yeah.
it all comes down to those building blocks we talked about. Tokens, you know, those words or parks of words.
Okay.
Even individual characters sometimes.
Yeah.
Remember the DNA of language for these models.
Right, those little pieces that make up the whole puzzle.
Exactly.
So both the input, our prompt,
Mm-hmm.
and the output, the LLM's response.
Right.
It's all just sequences of these tokens.
Precisely.
Okay.
But here's where the mechanics get really interesting. Input tokens, the ones from your prompt,
Yeah.
those are actually processed all at once.
All at once.
All at once.
Wow.
The model's not predicting anything with those. It's
Right.
just creating a representation,
Ah.
which makes it super fast.
So it's like taking a snapshot of the whole scene before diving into the details.
Perfect analogy.
Okay.
Now, the output tokens, the ones the LLM generates for its response,
Yeah.
those are created one by one.
One by one.
Like it's carefully crafting a sentence word by word.
So that's why they say these LLMs are auto-regressive.
Exactly.
They're always predicting what comes next. But that must be pretty computationally heavy, right? Generating those tokens one by one.
It is,
Yeah.
but the model's architecture,
Yeah.
specifically the transformer design,
Right.
that's cleverly optimized to handle this difference
Okay.
in how input and output are handled.
That makes sense.
Yeah,
But I have a feeling there's a trade-off some way.
you're catching on.
It can't all be sunshine and roses.
LLMs have a critical limitation.
Oh.
Their memory isn't
Funnel
infinite.
memory.
Yeah.
What does that even mean?
It comes down to something called context length,
Okay.
sometimes called the context window.
All right.
This is the maximum number of tokens that an LLM can kind of hold in mind
Hold in mind.
at any given time.
So it's like reading a book, but only remembering the last few pages.
Oh, that's a great analogy.
You get the gist.
Yeah.
But miss crucial parts of the story.
And this limitation is directly tied to the attention mechanism,
Right.
which we talked about in a previous deep dive.
Oh, yeah.
Attention helps the model focus on the most relevant parts of the input.
It's like a spotlight.
Exactly.
Highlighting important parts.
Right.
But if the stage is too big,
Yeah.
some things are going to be left to the shadows.
Exactly.
Like-
So if you give an LLM a massive document,
Yeah.
it won't actually process the whole thing.
Oh, wow.
Only what fits within its context window.
Makes sense.
Anything beyond that is essentially forgotten.
So knowing your LLM's memory limits is crucial.
Yeah,
Break down those large tasks into smaller chunks.
right.
Or summarize information before feeding it to the model.
You're thinking like a pro.
I've been doing it all wrong.
There's a common pitfall.
I've been stuffing way too much information into single prompts, hoping you just figure it out.
But understanding these limitations
Yeah.
helps us be more thoughtful and effective
Okay.
in how we interact with these models.
All right, so we've got the input and output figured out. We know these LLMs have a finite memory.
Yeah.
What else is going on behind the scenes as they're generating text?
Well, we talked about how they produce output one token at a time,
Right.
predicting the next word.
Uh-huh.
But it's not as simple as just picking the most likely word every time.
Oh, really?
There are different decoding strategies that come into play.
Decoding strategies, different approaches to composing a sentence.
Exactly.
Okay.
And each strategy kind of influences the style and creativity of the generated text.
Like choosing a different lens for your camera.
Perfect analogy.
All right, I'm all ears. Let's dive into these strategies.
So the most basic approach is called greedy decoding.
Greedy decoding.
Yeah.
So it's just always going to pick the most obvious path.
Exactly.
Right.
It's efficient,
Mm-hmm.
but the output can be a bit predictable and maybe even a little dull.
So it's like a robot following the same path every time.
Yeah.
It gets you from A to B,
Right.
but it's not very exciting.
Now, if you need a little more flair, we have something called beam search.
Beam search.
Yeah.
Okay.
Imagine you're exploring a maze.
Okay.
Instead of sticking to one path, you send out multiple scouts to explore different options simultaneously.
So it considers multiple possible word sequences
Exactly.
in the same time. Wow.
It keeps track of several promising beams of options.
Okay.
And evaluates them at each step.
So it's like our Swiss Army knife,
Yeah.
versatile and powerful.
Right.
But maybe not the fastest option.
Exactly.
For a simple task.
Now, if you're feeling adventurous
okay.
and you want to inject some randomness,
Ooh.
there's temperature sampling.
Temperature sampling. So we're adding a little unpredictability.
Exactly.
To the mix.
Higher temperature means the model is more likely to choose less probable words.
Interesting.
Leading to more diverse and surprising results.
So that's like adding the touch of jazz improv.
I love that analogy.
Yeah, you might get some brilliant riffs, but also some off-key notes.
Lowering the temperature
okay.
makes the model stick to the more probable words.
So it's more focused,
yeah.
but potentially repetitive.
Right.
Okay, so temperature sampling is like our wild card.
Exactly.
It can lead to some really creative output, but we need to use it judiciously.
And then we have two more that offer different ways to control this token selection process.
Right.
First, there's top K sampling.
Top K, break that down for me.
Instead of considering all possible tokens, the model only focuses on the K, most likely ones.
So we're curating a playlist of the most likely words.
Exactly.
It's like choosing from a greatest hits collection.
Right.
It might miss some hidden gems.
Sure.
But it guarantees a certain level of consistency.
And coherence.
And
finally, we have nucleus sampling.
Nucleus sampling.
Also known as top P sampling.
Okay.
Which is a more dynamic and adaptable strategy.
How so?
Well, instead of fixing the number of choices like in top K, nucleus sampling adjusts it based on the situation.
Interesting.
It chooses from the smallest set of words whose combined probability exceeds a certain threshold.
So if the next word is pretty obvious, it might only consider a handful of options.
Yeah.
But there's more uncertainty.
Right.
It expands its horizon.
You nailed it.
It's like a smart filter.
Yeah.
That adjusts its settings.
Exactly.
Based on the context.
All about finding that balance between predictability and diversity.
Wow. I'm starting to see how much nuance goes into this.
Yeah.
Generating seemingly simple text?
It's not just about blindly spitting out words.
Right.
There are all these intricate strategies at play behind the
And that brings us to one of the most crucial and often underestimated aspects of working with LLMs.
Yeah.
Prompt engineering.
The art of crafting the perfect instructions.
Yeah, this is where I think a lot of folks, myself included, could use some guidance.
Prompt engineering is all about creating effective inputs to guide the LLM towards the desired output.
So it's not just about typing in any old question or request.
Definitely not.
Got it.
These models are powerful, but they need crystal clear instructions.
Okay.
It's like giving directions to someone who takes everything literally.
Right.
You have to be incredibly specific.
All right. I'm ready to learn the secrets of effective prompt crafting.
Here we go.
What are some fundamental tips to keep in mind?
First and foremost, clarity is king. Be explicit about the task instead of just saying write something.
Right.
Tell it precisely what you want.
So, write a short story about a cat who travels to the moon.
Exactly.
Okay, no more vague requests.
Then context is everything.
Context.
Don't assume the LLM knows what,
Right.
If you want it to summarize an article, provide the article in the prompt.
Got it.
No mind reading aloud.
LLMs aren't psychic.
And finally, it has specify the format you want.
The format.
Best. Poem. And code in a specific language. Tell it.
You can't guess.
Okay, so be specific, provide context, and outline the desired format. Exactly.
Like writing an instruction manual.
Yes.
For a very literal-minded assistant.
Precisely.
Mastering those basics is crucial.
Right.
And once you've got those down, you can start exploring some more advanced techniques. Like zero shot, few shot, and chain of thought prompting.
Those are for the seasoned prompt engineers.
Ooh, can you give us a sneak peek?
Absolutely.
Into what those entail?
Think of zero-shot prompting, like giving the LLM a pop quiz.
A pop quiz.
You're relying solely on its pre-trained knowledge and ability to generalize.
Right.
You might ask, what's the capital of France? And expect it to answer Paris without any further context.
You were testing its general knowledge
and
ability to connect the dots.
Now with few-shot prompting. You're providing a few examples within the prompt to demonstrate the desired behavior.
So it's like giving the LLM a crash course.
Perfect analogy.
Showing it a few dance moves before asking it to join in.
You got it.
Okay.
You might show it a couple of sentences labeled as positive or negative sentiment.
Right.
And then ask it to determine the sentiment of a new sentence.
So we're guiding it with specific examples.
Exactly.
What about that chain of thought prompting?
That one's a fascinating technique.
Yeah.
It encourages the LLM to think step by step,
Okay.
making its reasoning process more transparent.
So it's like we're peeking into the LLM's mind.
Yes.
Watching it work through the problem.
And this often leads to more accurate and insightful results.
This would be valuable for tasks that require logical reasoning or problem solving.
Imagine asking an LLM to solve a complex word problem.
Okay.
Instead of just stating the problem, you could prompt it to break it down into smaller steps.
So it's like we're asking the LLM to show its work.
Exactly.
Instead of just giving the final answer.
You got it.
Like solving a math problem step by step.
Precisely.
Wow, this is really fascinating stuff.
It is.
I'm starting to appreciate the level of control we have over an LLM's output.
It's powerful.
And how much thought goes into crafting these effective prompts.
And it's only going to become more crucial as these models become increasingly integrated into our lives.
Well, on that note, let's take a moment to process all this amazing information.
Okay.
When we return, we'll delve even deeper into the world of prompt engineering.
Sounds good.
And explore how we can harness these advanced techniques to unlock the true potential of LLMs.
Can't wait.
Don't go anywhere.
I'm here.
All right, welcome back to the deep dive. My brain is like still buzzing from that first segment.
I know, right?
It's incredible how much is happening behind the scenes when an LLM generates text.
It's a testament to how complex and ingenious these models really are.
Right, and we've only just scratched the surface.
Oh, yeah.
We covered the basics of inference, those tokens and context length and decoding strategy.
Right.
But I'm really eager to learn more about those advanced prompt engineering techniques you mentioned.
Right.
Zero shot, few shot, and chain of thought prompting.
They're super powerful.
Yeah, they all sound so powerful.
Mastering those techniques can really take your LLM interactions to a whole new level.
Okay, so let's start with zero shot prompting.
Okay.
You described it earlier as like a pop quiz for the LLM.
Right.
But I'm still a little fuzzy on how it actually works.
Okay, so imagine you walk into a library with a question in mind.
Right.
You don't need to, consult a specific book or ask the librarian for directions. You just kind of trust that the vast collection of knowledge within those walls holds the answer.
So with zero-shot prompting, we're relying solely on the LLM's pre-trained knowledge.
Exactly.
Like we're saying, here's a challenge, impress me with what you've already learned.
Precisely.
And it's effective for tasks that involve common sense, factual knowledge, or simple language understanding.
You could ask it to translate a sentence into another language.
Oh, wow.
Even if it hasn't specifically been trained on that language pair.
So it can just figure it out?
Or you could ask it to classify the sentiment of a movie review.
Interesting.
Based on its understanding of human emotions and language.
That's amazing. So it's like tapping into this vast reservoir of knowledge and expecting the LLM to just extract the relevant information.
Exactly.
But what if we needed to perform a more specific task?
Okay.
Something that requires a bit more guidance?
That's where few-shot prompting comes in.
Okay, few-shot prompting.
This technique is all about providing a few illustrative examples within the prompt itself to demonstrate the desired behavior.
So instead of just relying on the LLM's general knowledge,
yeah,
we're giving it some concrete examples to work with.
Exactly.
It's like showing a chef a few sample dishes.
I love these analogies.
Before asking them to create something new.
The LLM can pick up on patterns and apply them to new situations.
Okay.
It's really effective for things like summarizing articles, writing different kinds of creative content, or even generating computer code.
Can you give us a specific example of how few-shot prompting works in practice?
Imagine you want the LLM to write product descriptions that are concise and engaging.
Right.
You could give it a few examples of well-written descriptions, highlighting key features and benefits.
Got it.
Then you ask it to generate a new description for a different product, but following that same style and structure.
So we're essentially providing a template.
Yeah, like a set of guidelines.
It's like giving the LLM a crash course in copywriting.
Exactly.
And the more examples we provide, the better the LLM will understand our expectations.
And be able to generate that desired output.
This is really making me rethink how I approach prompting.
Yeah.
I can see how carefully crafting those examples can really impact the quality and relevance of the LLM's responses.
And these techniques are constantly being refined
and
improved as we learn more about how LLMs process information.
That's so cool.
And learn from examples.
Okay, so zero-shot prompting taps into that pre-trained knowledge.
Yeah.
Few-shot prompting adds a layer of guidance through examples.
Right.
What about chain of thought prompting?
Okay, so chain of thought prompting, or QT for short.
QT.
It encourages the LLM to think step by step.
Okay.
Making its reasoning process more transparent.
So it's like we're peeking into the LLM's mind.
Yes.
Watching it work through the problem.
Exactly. And it often leads to more accurate and insightful results.
I can see this being valuable for tasks.
Yeah.
That require logical reasoning or problem solving.
Imagine asking an LLM to solve a complex word problem.
Okay.
Instead of just stating the problem, you could prompt it to break it down into smaller steps.
So it's like we're asking the LLM to show its work.
Exactly.
Instead of just giving the final answer.
Precisely.
So instead of saying John has 5 apples and gives 2 to Mary, how many does John have left?
Right.
We would say John starts with 5 apples. If he gives 2 to Mary, how many does he have left? Well, if we subtract 2 from his original 5, we can calculate that John has 3 apples remaining.
Perfect example.
Wow.
By explicitly prompting the LLM to articulate its reasoning, we're kind of guiding it to approach the problem systematically.
So it doesn't make careless mistakes.
And avoid those careless mistakes.
That's incredibly clever. I wonder if chain of thought prompting could also help identify potential biases?
Oh, that's interesting.
Flaws in the LLM's reasoning.
That's a great point, and it highlights one of the key benefits of COT prompting, making that thought process visible. We can better understand how it arrives at its conclusions, which allows us to identify and potentially address any biases or inconsistencies.
This is really opening my eyes to the power and potential of prompt engineering.
It's not just about giving the LLM instructions. It's about shaping its thinking, guiding its reasoning, and unlocking its full potential.
And as we continue to develop and refine these techniques, we're not just improving the performance of LLMs, we're also gaining a deeper understanding of how they work and how to communicate with them effectively.
It's a really exciting field.
It is. But with all this power comes a great responsibility.
Absolutely. As LLMs become more integrated into our lives, we need to be mindful of how they can be used, misused, and even abused.
We need to consider ethical considerations, address potential biases, and ensure that these models are developed and deployed in a way that benefits society as a whole.
That's a great point. Let's take a moment to reflect on the ethical implications of this technology. When we return, we'll explore the challenges and opportunities that lie ahead as we navigate this brave new world of LLMs.
Welcome back to the Deep Dive. It feels like we've been on this incredible journey today. Exploring this intricate world.
It is.
LM inference.
Definitely.
We started with understanding those basic building blocks of language.
The fundamentals.
And now we're masters of prompt engineering.
Oh, yeah.
It's been mind-blowing.
It has. And as we wrap up, I think it's important to take a step back and think about those broader implications of this technology.
We've talked about how powerful LLMs are, how they can generate human quality text and translate languages, write different kinds of creative content.
And even code.
Even code.
Pretty amazing.
But with great power comes great responsibility.
Absolutely. As these models become more common, more integrated into our lives, we need to be mindful with those consequences, both good and bad.
I think one of the biggest concerns is misuse.
Oh, yeah, for sure.
If LLMs can generate realistic and persuasive text, couldn't they also be used to spread misinformation? Or create harmful content?
This is a valid concern, and it's one that researchers and developers are very aware of. They're working on ways to detect and mitigate those risks of misuse, like developing tools that can actually identify LLM-generated text and flag content that might be harmful.
That's good to hear.
Yeah.
But beyond intentional misuse, I'm curious about the unintended consequences.
Oh, yeah.
Could these models, even when used with good intentions, accidentally perpetuate existing biases or stereotypes?
That's another crucial point. I mean, LLMs are trained on huge data sets of text and code. And those data sets reflect the biases and prejudices that we see in the real world. So if we're not careful, these models could amplify those biases.
That makes sense.
Leading to unfair or discriminatory outcomes.
It seems like a delicate balancing act.
It is.
We want to harness the power of this technology, but also make sure it's used responsibly and ethically.
It requires a multifaceted approach. We need research and development to improve the models themselves. make them more robust and transparent and fair.
Right.
We need clear guidelines and regulations to govern their use, especially in areas like healthcare or finance or education.
Yeah.
And we need to educate the public about what these LLMs can and can't do.
I think that last point is so important.
Yeah.
As these models become more powerful and easier to use.
It's crucial for everyone to understand.
Yeah.
How they work, what they can do, and what they can't do.
Because we're all going to be interacting with them in the future.
Exactly. We need to demystify this technology, make it understandable, approachable, so people feel empowered to use it for good.
Well, this deep dive has definitely helped me gain a much deeper understanding of LLMs.
I'm glad to hear that.
And I hope it's done the same for our listeners.
Yeah, me too.
We explored the technical details, the creative possibilities,
the ethical considerations.
It's been quite a journey.
It has.
And I think it's just the beginning.
I agree.
As research and development continues, we're going to see even more amazing applications of this LLM technology in the years to come.
For sure.
It's exciting, but also kind of daunting.
It is.
It feels like we're standing at the edge of a new era.
I think we are.
One where AI is just becoming a bigger and bigger part of our lives.
It's a new era, and we need to approach it with both enthusiasm and caution by understanding the tech embracing the potential and addressing those challenges. We can shape a future where LLMs really augment our capabilities and enhance our creativity and ultimately make our lives better.
Well said. I want to thank you, our expert.
Oh, you're welcome.
For sharing your incredible knowledge and insights with us today.
It's been my pleasure.
And to our listeners, thank you for joining us on this deep dive into the world of LLM.
It's been fun.
We hope you enjoyed this episode of The Deep Dive.
Yeah, thanks for listening.
Until next time, keep exploring, keep learning.
Stay curious.
And keep asking those big questions.
A 7.19.